So then we would lose, we usually get on 45, so then we lose 5 for our class 5. So probably something like 35, maybe? The assembly is right after 5th grade, right before lunch.
So your assembly goes fast to get along lunch.
Yeah, exactly. Okay, what you guys write down for point slope form? I heard you guys saying it, say it to me.
One. Minus y1.
It's very dramatic.
Times x minus x.
Oh my. Okay, so the x1, y1 is what we're going to technically call the point of tangency. Because you guys remember a tangent line skims in how many points? It skims across 1 point. It skims across hitting 1 point, right? Tangent line skims hitting across 1 point. So that 1 point is the x1, y1 that we're going to use because all the other points are not on the curve. So that x1, y1, the point that we're going to use is the point where it skims the function, or it skims f of x. So we can say something to the effect of, okay, if this is a tangent line, and if it's tangent to y equals f of x at the point of tangency, x1, y1, we're going to embellish upon this just a little bit. Yeah.
You know you wrote the point slope on the bottom right.
Well, I kind of copy and pasted that to make this 2 pages, or sorry, 1 page instead of 2, so. Originally it wasn't there, but yeah, I realized it's there right. Now, coming back. I could actually rewrite this equation to be y minus f of, now I'm going to go ahead and make it just a little bit easier. Maybe you don't realize it's a little easier. We already talked about how x1, y1 could be the point of tangency. But sometimes, especially in calculus, because that's what we're doing right? Pre-calculus. Sometimes, especially in calculus, they don't tell us an x and a y. Sometimes they just tell us an x. But if they give us a function, well, we can take the x and we can plug it in the function and get the y. Because who is f of x? Y. Yeah. So if they give me the x, I can plug into f of x, I can get the y. And that's what this little so y1 could be f of x. Maybe they don't give me both. Maybe they just give me one, so I have to go find my y. Okay, no big deal. But I'm not just going to be finding my y for a tangent line. I'm also going to be finding my slope. And not using the old school y2 minus y1 over x2 minus x1, because I won't have 2 points, because I only have one. Tangent line, 1 point. Skims at 1 point. Slope at 1 point, right? So, another type of problem that you might see that we didn't specifically get to do an example of yesterday is the following. Using the definition of the derivative, or they might say the limit process, to find the derivative, or the limit definition of the derivative, find the equation of the tangent line. So do I just want slope? No. But do I need slope as a part of this answer? Yeah. Yep. F of x equals 5x squared, fx equals negative 2. And okay, there's the point slope form. Okay, so now that we've written all this stuff up above, you technically didn't need that. True?
True.
Okay, but what do you need to do? If you don't mind, just to get our brains in the right headspace, to get us in the right direction, to get us going, pointing at least the correct way to go. Can I go ahead and start writing point slope? No. Let's leave some more room for slope. Okay, what have I left blanks for? Everything that's missing. So what's something that I know I can plug in right now?
5x.
I cannot plug in 5x squared, but I can plug in negative 2 is my x. There's my x. But hold on, I don't like just having an x. I really wish that I also had a y. Well then use. So don't say plug in 5x squared. That's wrong, but I'm going to plug in 2 5x squared. don't plug in 5x squared. It doesn't belong anywhere. The 5 and the x and the square doesn't belong anywhere. But I'm going to plug in 2 the 5x squared, because the y is going to be 5 times negative 2 squared, as shown by my y equals f of x wherever he is equation. And so what is my point of tangency, even though they were hiding it from me? Negative 220. They were hiding it from me. But if they tell me x equals negative 2, I can say, well, where are you, negative 2? Oh, you're at 20. Okay, cool. Boop, 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 boop. All right, so I got my x. Check. I got my y. I got my point, my x1, my y1, my specific point. But what am I missing? My derivative, aka my slope, because what finds the slope of the tangent line? The derivative. So I need f prime of x. And what did we learn yesterday about f prime of x? It's defined. Okay, there is a difference quotient, but what should come first?
Limit.
It's like saying the distance formula doesn't need a square root. The distance formula does need a square root. X2 minus x1 squared plus y2 minus y1 squared with a square root. So a derivative needs a limit. There we go. And how's that difference quotient go again? F of, are you guys good enough with the difference quotient? You know what I'm doing?
Yep.
So f of x plus h minus f of x, right? All over h. Now, am I finding the slope I need or all the slopes? And I'll narrow it down later. Okay, as you find shortcuts, I told some of you can go looking for shortcuts about how to find derivatives without limits of polynomial functions. And some of you found a shortcut. Once you know shortcuts, you're going to go straight to f prime of x. You're not going to do that crazy f prime of a thing. I'll remind you of that in just 1 second. But you're going to know in f prime of x, it's very important that you realize whenever you're finding f prime of x, you're finding all the slopes. So some of you are already doing this. You're doing this the definition way, which is good. Hopefully you guys end up with 5x squared plus 2hx, which will be 10xh or hx, plus 5h squared minus 5x squared. Hopefully you foiled that and did not kill a poor little helpless puppy. You would have pulled out, hopefully, that h for the purpose of removing the whole, right? Oh, doesn't this guy have an h? What happens when you plug in h to 0? 5h cancels to 0. I have 10x, which is left. I plugged 10x in! Nope. That's just as wrong as me saying that you cannot plug in, or I should say, Kyle saying, plug in 5x squared. No, but hold on. Why did I make a big deal? No. You don't plug in 5x squared. It's not a y1. It's a whole equation of all the y's, right? I need an x1 and a y1, a specific x, a specific y. I can't plug 5x squared in as a specific y. He's general. He's all the y's. We had to take the negative 2, plug in 2 5x squared, and get the y for my y1 spot. So what's going on with the derivative? The exact same thing. If I find f prime of x is 10x, that's all the slopes. What slope do I need for this line? I need f prime of negative 2. What do we always do when we know what x equals all of a sudden? Plug it in, plug it in. So what is the slope? Now, a quick reminder. I did show you yesterday, which is important for AP multiple choice questions in calculus A, B, and BC. So if some of you are like, I don't care about limits anymore, I found a shortcut. You need to realize this would have also been the answer to the limit as h goes to 0 of 5 times negative 2 plus h squared minus, although there's no way they would have shown that to you, but I'll go ahead and give it to you in that form to make it easy. There's actually even another way of doing this. negative 20 is the answer to f prime of negative 2 going that direction using the definition of the derivative and then plugging in negative 2 at the end. But negative 20 is also the answer to this, which would also be f prime of negative 2, where f is equal to 5x squared. And it would also be the answer to f prime of negative 2, where f equals 5x squared. This one, isn't this the definition of the derivative? But what has changed? Instead of an x, what is there instead plus h? It's going straight to the answer. So if you had simplified this, you would have gone straight to negative 20, which would have been great unless the next problem was like, oh, hey, use that function again and find me another tangent line. You're like, ugh, I have to do it all over again with a different x. But if you did it this way, couldn't you just say, instead of plugging in negative 2, I'll plug in the 5 or the 10 or the 12 or whatever other one they want. This one I can use over and over again. This one is one shot only, one time only, one time each. Okay? Anyway, long story short, what's my slope? Negative 20. So I come up here. Oh, nope. Need more. What am I going to plug in this spot? Is this an equation of the tangent line?
No.
It is, but is it in the fully simplified nice form that most of you are used to seeing lines?
No, it's very ugly.
So is there another way of writing it? The answer is yes. Will there be another answer that looks a little bit nicer in the back of the book? The answer is probably yes. But in calculus, to be honest, we probably stop there most of the time. Not all the time, but most of the time. If it was multiple choice, it's very possible they would make it look nice and pretty like your back of the book. In which case you would distribute the negative 20. You'd end up with negative 20x. You'd end up also with minus a negative 2 is plus 2, but times a negative would be minus 40, but then adding 40. I doubt they would factor it. That's probably the nice one. But if it was a long answer problem, I technically have the calculus kids stop here because I'm like, man, if you start doing mental math to simplify, you might make a mistake. And sadly, the calculus guys, when they grade the long answers, even if you had the right answer here, if you make it wrong and accidentally were to put like minus 40 or plus 40, they'd be like, well, that's great and all. You almost got that 1 point, but now I'm taking it away. But anyway. That's just a peek into the world of calculus. So, we have just found an equation of a tangent line with each of its pieces. Who is the x? Who is the y? Who is the slope? Using definition of the derivative. And then we said, okay, we could make it look pretty if you want. So, kiddos, I want you guys to go ahead and try to tackle the following problem that we technically have not exactly done example like. But you should have all the pieces to solve. Go ahead, collaborate your groups. I'm only going to give you a couple minutes. I'm going to pause the video so I'm not just recording blank space. At one point, you can like factor it. Like a 9x is like
oh. It's the first section. So it's x cubed plus 3x squared h plus 3x h squared h minus 5x minus 9h minus 3x squared minus 9x.
Did anybody get a little intimidated by the cube?
Yes.
But then did you remember Pascal's triangle?
No.
Yeah.
Oh yeah. What?
So
it's x cubed plus 3x squared h plus 3x h
You guys
squared.
see my Pascal's triangle?
Yeah, oh my god.
1, 3, 3, 1.
这是从性质的，
Makes life easier.
然后把
Oh, we still
然后
have
放到这里
3x.
把块钱把这个题目袋里面拆开，
Alvin, what?
然后一个一个块钱，然后再把 h 约量，然后 h 等于0，
Oh, that's really
然后
good.
最后的结论。
I'm not gonna take it. I'm sorry, I'm getting sick over a math problem. I can't tell you how to do
What
it.
is it?
It's not backwards, is it? Woo! How'd that go?
What? And then you take out an H.
I cubed using Pascal's triangle of 1, 3, 3, 1. Kind of cheated a little bit. I did FOIL and then do polynomial
Misty,
multiplication.
forgive me for it. I'm not going to bring one
And I distributed. And distributed. And distributed.
How'd you get from 9x squared to
No.
like the bottom last
Oh,
to
oh.
9x
Remember, the limit disappeared because I'm plugging in 0 for H. So only the guys without H are going to remain. Then it says, then use the derivative to determine any, awkward, there's a word missing, points. Any points. Okay, any points on the graph. Boop, boop. On the graph of f at which the tangent line is horizontal. What does it mean for a line to be horizontal? Tangent line, okay, line is y1 equals m times x minus x1. What do we know about if it's horizontal? Do we know what points it goes through? I'm not sure I know x's or y's, because couldn't a horizontal line in space go anywhere?
Yes.
But what's true about all horizontal lines? Wherever they are in space, whatever
Y
points they're going through.
is the same.
The y is the same, and the y is the same because what happens to all the x's?
Always.
Well, the x's include infinitely many x's, but why?
Because it's horizontal.
Why is it only one y?
on the same one.
Why is it a y equals y1 line? Because the slope is
zero.
0. This cancels out, and he adds to the other side. It's always y equals a, or y equals c, or y equals b. It's always going to be y equals because the n is 0, and it cancels out all the x's.
So basically, it's still that.
So m equals 0. Wait a minute. If m equals 0, then how are we supposed to figure out when the tangent line is horizontal?
Tangent line's always horizontal.
Isn't derivative all the slopes?
Yeah.
So can't I say, well, Mr. All the slopes, when are you all the slopes equal to? So you set the derivative equal to 0, or set all the slopes equal to 0, and say, okay, well, if you're all the slopes, then please, Mr. X, what would you have to be in order to make the slope specifically 0? You guys see if
One.
I add 9 and divide by 9, I get x squared equals 1, which means at both positive and negative 1. At both positive and negative 1, I'm going to have horizontal tangents. Wait a minute, horizontal tangents. Don't I know the end behavior of any cubic function that if, as long as the leading coefficient is positive,
Is it down up?
he goes down that way and up that way? Then didn't we just figure out that at negative 1 and at positive 1 using calculus when we set the derivative equal to 0? We just figured out, well, hold on, can't I plug in negative 1 and figure out what this is going to be? Negative 1 is negative 3, negative 3 plus 9 is 6. Can't I actually figure out exactly where positive 1 would be negative 6? Can't I figure out exactly where and how this cubic goes?
Whoa.
Do you guys remember way back when, whenever we were graphing nasty polynomials in chapter 2, I think, we had to plug sufficiently other points to kind of make a guess as to what our graph looks like for cubics and quartics and quintics and all the rest? Can someone help? You know? Thank you. She was like dangling, being like, anywhere. But now with calculus, guess what we can find? What happens at horizontal tangents? Do you Remember how with parabolas we could find the vertex using vertex form, but for cubics and quartics, and all we could use were the calculator because I said you didn't know calculus yet?
Whoa, we go calculus now.
Now you can find maximums and minimums almost as good, if not better, than your calculator, because sometimes they do the weird like 0.0000 or 0.99999. You can do it better than that. Here's a graphing utility confirmed. Adam, does it look kind of like that? Yeah. Cool. You just graphed it. Now, Adam said something kind of cool just a second ago, because we're technically at the end of section 12.3, because I know that he researched something that I said in class yesterday when I said there are some shortcut rules for derivatives. If you guys look back in your notes for section 12.3, I want you to find me some derivatives. We're going to look and see if we can find a pattern. I want the original function, foo with f of x, and then I want the derivative function. So find an example in your notes where we found a derivative, a general one, not a number, but like with an equation. Kyle, do you have one? Something that we found a derivative of. Or f prime of x of, or g prime of x of. Okay, Adam found that we took or found the derivative of 3x squared minus 2x. And what did we get that derivative to be at the end of all of our work? 6x minus 2. We just did this one. We can add this one, right? F of x is equal to 3x cubed minus 9x. F prime of x equals 9x squared minus 9. Did anybody find any? I thought we had a g. Didn't we have a g in there somewhere?
4 over x.
4 over x, which is the same thing as 4x to the negative 1.
Whoa.
In case you're curious. What did our g prime end up equaling? Sorry. Too much fun, not double prime. I was tutoring Count 2 last night. G prime. Ah! G prime. We got to be negative 4 over x squared, but P.S. that comes from negative 4x to the negative 2. You want me to give you some more? What if I was to give you h of x is equal to something like 10x to the 4th power? H prime would end up equaling, without me doing any work, because who really wants to do Pascal's to the 4th? Well, 14641 isn't too bad, but it's really just going to be 40x cubed. And what if we were to do something like, I don't know, let's go back to f because I'm running out of letters and I is imaginary. What if I was to do something like f of x is equal to, I don't know, maybe something like 27x squared. Do you guys know what f prime of x would be? 54x. How are they doing this without using a big old nasty limit as h goes to 0? F of x was h minus f of x all over h. Gavin, what do you see?
So basically, you take the coefficient or the number in front of the x and you multiply it by the power, and so that gets you the number that is in front of the x in the derivative.
Multiply it by the power. So kind of like I bring him down.
Yeah.
So this would be 2 times 3.
X. But then you keep the same one.
But why is it?
The power goes down.
The power
And the
goes
power
down
goes
by
down
1?
Yeah.
So wait, so this one came down. That would be 3 times 3, x to the 3 minus 1. Oh yeah, it is x squared. Then this one I would bring down, and then that'd be negative 1 times 4, x to the negative 1 minus 1. Oh, negative 1 minus 1 is negative 2. But wait a minute, what about these dudes? What happened to him? What's my power?
They go down 1.
So 1 comes down, 1 times 2, and x to the, if the power goes down 1, what do I have?
0.
Oh, what's anything to the 0 power?
Yeah,
Oh, so 1 times 2 times 1 is 2. Okay, so this one, the 1 would come down, and 1 times negative 9 is negative 9, and x would be to the 0 power, which takes the x away. Oh. So then this one, do you guys agree that the 4 comes down to become 40, and what happens to the x?
and then it goes down.
Now he's cubed. You guys agree that 2 comes down to join 27 to make 54, and it goes down 1? You guys ready for the power rule of derivatives? If you are trying to find principle of having a number in front. Sometimes there is and sometimes there not. But let me put a number in front. So A is a constant. There's a number in front.
Well, then it would be 1 if there wasn't a number.
True.
Like if there was just x squared,
A
then
would be
wouldn't it be 1?
Yeah, so there's still technically a number in front, right?
Whatever, yeah.
What did you say about this?
It goes down.
Bring down the n. Your power goes down by 1. Dun, 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 dun. That's a really important rule in calculus.
That's a whoa.
Why is that pretty cool? How many times in homework will it ask you to find a derivative?
Most of the time.
So if it's asking to find a derivative, now technically, hold on, didn't I just show you yesterday a multiple choice problem in the calculus AP practice exam that has a limit? It was super important to be able to read and decipher and work with that limit. And I told you there was some rule behind what happened that I couldn't really explain to you, but Wolfram knew it, so we used it, that the derivative of ln of x is 1 over x. Another rule. These rules are just shortcuts to the actual definition of what's really being done as far as the limit as h goes to 0 of f of x plus h minus f of x all over 8. So this is what's really happening, but with polynomials, someone along the way figured out every single time this is ultimately going to happen. Which means, in homework, do I want you to use the shortcut rule? No, not yet. But wait a minute, if you can't use it to solve the problem, what could you use it to do?
Check.
And get good at the rule all at the same time. Now, what do you think about the quiz, the test, the final? Well, maybe I'll let you use said power rule, unless I say something like using the limit definition of, and a lot of homework said that, didn't it?
Yeah.
So use the definition or use the limit process or use the limit definition. So they gave you that wording because it's understanding there is a shortcut rule, and that shortcut rule, believe me, is something that you're going to be using a lot if you ever take calculus. But for right now, it's a really, really, really cool technique to be able to know at the end of something really long, which I don't usually give you cubics, because Pascal's triangle makes it a bit messy. But couldn't you have checked to make sure that 9x squared minus 9 was correct by using the power rule, 9x squared minus 9? But is homework just finding derivatives the long way? No, it's knowing what they are. Derivatives are slopes of tangent
Know the
lines.
foundation.
Knowing how to use them to build a tangent line. Knowing in the slope spot will go a specific derivative, not the general one. We need a point at or with a slope, not all the slopes and all the points. That's not going to be helpful. You gotta get specific sometimes. And then some extra things come in like, hey, let's make it horizontal. The slope is equal to 0. The derivative is equal to 0. Some connection. All right, cool kids. Finish up 12-3 for tomorrow. Corrections are due Friday.